Hello students, good afternoon to you all. Welcome back again to another video tutorial session from the AP3X Institute of Applied Mathematics Education. My name is Akin, your math instructor, and particularly the contents posted here on this channel are primarily on the focus of the CSEC, CCSLC, SEA exams curriculum. Yes, and of course I do post other contents. Well, I will be posting other contents that are related to EDXL exams, City and Guilds, and of course SAT exams. Olympiad math questions also will be coming up, and also calculus videos, college math videos will also be posted. But for the most part, just to build the family up on this particular channel here, I focus primarily on the CSEC curriculum. All right, so of course in today's video we're going to be looking at an introduction to algebra. This is in fact part one of a two-part series in which I'm going to be going through the whole basic concepts and applications related to algebra, a topic that is feared at every level in math. But why fear algebra if you have a strong fundamental? Obviously, a lot of students do not have very strong fundamentals, and particularly the ambiguities and the misunderstanding, misconceptions of concepts and terms and so much more in algebra has been misunderstood, hence why you may or may not struggle. Nevertheless, here we're going to be jumping into this particular tutorial. So if this is the first time here on the channel, hit that subscribe button below, guys. Turn on your post notification bell to be notified whenever I post contents on a weekly basis. And of course, hit the like button if you have gotten value from any of my other videos, obviously including this one. So let's jump right into the lesson. Okay, do not forget to leave some comments down below, guys. Love to talk to you. Algebra is an abstract branch of mathematics that uniquely creates a relationship between what we know as letters, or referred to as unknown values, and numerical quantities known as known values. So algebra isn't particularly something that you're going to be doing on a regular basis, because I find a lot of my students ask me the question of where and when do I actually use algebra in real life. Algebra is an abstract world. There's aspects of algebra that we are using currently in our daily lives. We just don't know that we are, but it's more of connecting the known with the unknown and creating a relationship between them. Yeah. So in algebra, you're gonna find that algebra deals mostly with the alphabet and connecting numbers to the alphabet. And so you're gonna find, particularly most of the time, that in algebra you'll find that we use the very most commonly used letters X. Say here, pardon me, say we use here X. Okay, here we go, guys. Sorry about that. X, Y, A, B, P, and Q. Those are the letters that we most often use, but we can use other variables as well. Now, there are some terminologies though that math instructors, tutors, teachers, there are some terminologies that we use when we're explaining, and if a student is not fundamentally aware of these terminologies, then at times they may be lost whenever a concept is being explained. So there are two aspects of algebra which you're going to be encountering: a simplification department and an evaluation or calculation or solving department. Solving is when we get to the topic of equations. Simplifications base is surrounded or is connected to algebraic expressions. Okay, so the very first terminology that you will hear us mention to you as students is variable, or what I would refer to as also base. These are synonymous with each other, or they're used interchangeably by instructors. Now, this is a letter that is used to represent an unknown quantity in an expression or an equation. Okay, so as I had mentioned earlier, X, Y, P, Q, A, and B, and so on are just the main letters that you're going to find in textbooks, formula books, practice papers, exam papers. These are particularly the letters we're going to be using, but any letter can be used. Yeah? Okay, so that's what we refer to as variable. Now, the next terminology that you're going to find us talking about a lot, especially when it comes to the addition and subtraction aspect of, well, in fact, add, subtract, multiplication, and division aspect of algebra, is the word coefficient. Coefficient. This is a numerical quantity that appears before the variable. So when earlier I had mentioned to you that X, Y, P, Q, A, and B are the common variables, notice there wasn't any number placed in front of them. Well, in fact, there is a number here, but it's an understood value. So this really means 1x, 1y, 1p, 1q, 1a, 1b, but we don't usually write the 1. It looks a little awkward, hence we just state that it's an understood an understood value of 1. So then what's gonna happen then? We end up with expressions like 2x minus 3y half a minus 3/4 b 0.9p, expressions like these. Now these expressions are what I would call monomial expressions. Okay, monomial expressions. Why do I call them monomial expressions? Because they have one unknown variable here, x, y, a, b, and p. So you'll find here that the numbers that I've circled in red here are the coefficients. So the coefficient of 2x is 2, the coefficient of minus 3y is minus 3, the coefficient of half a is a half, the coefficient of minus 3/4 b is minus 3/4, and the coefficient of 0.9p here is in fact 0.9. Next, we're going to be looking at what is referred to as the power or the exponent. And this is a very small number. Yeah, small not in terms of quantity but in terms of its size on paper. So this is a very small number. We usually find this at the top left or the top right hand side of the variable. So you're going to find here that this is a very small number that appears above the variable to the top right here. So if you look here, that I have some expressions: 4x squared minus 2y cubed 1.7a to the 4 minus 2 over 5b to the negative 5. You find that in purple are the actual expressions, but circled here in red, here and here and here, right here, these are called powers. These are called powers or exponents. And it's not just limited to like what you're seeing here on screen, positive 2, positive 3, positive 4. It could be minus 2, minus 3, minus 4, as well as minus 5. Okay, it can actually be decimals. Well, at least not at the CSEC level. Well, it can be at the CSEC level, but we don't commonly find expressions at this level with decimal powers, but it can be decimals: 0.2, 0.3, 1.4, 2.5. Yes, it could also be fractions as well. Advanced indices problems, law number 3 and 4. We're going to get into that on the channel in a few weeks. Here, 2, 3, 4 fractions. So fractions, decimal whole, but for the most part here, just to keep it simple, keep you in gear, while still keeping you aware that for now we're going to be working with positive and negative, as well as a few fractions here or there. Now, when everything combines together, then that's when we get what is known as a term or an expression. Okay. Now remember that you're going to be exposed to a wide variety of expressions, monomial expressions, binomial expressions. You're going to be looking at, say here, trinomial expressions and what is known as quartic expressions at a higher level. Okay, well, quartic refers to the power, but you can have expressions that have 4 unlike terms as a simplified answer. Now, that's when everything combines. So notice here I've circled in green that everything here becomes what is known as a algebraic term. Okay, but we use the word term and expressions interchangeably depending on what lesson we are trying to bring across here. Okay, so the next thing that we're going to be moving on next to is understanding what are like and unlike terms. And already in the definition, you see where I've already circled in green that we are already using some of the stuff that we have already learned. Term, base, expression. So by the definition here, like terms, these are algebraic expressions that have the same base. So here we have 2.5x, 2x minus 3x, a quarter x minus 2/3 x minus 5.4 x. What makes these expressions alike? It is in fact what I've circled here with a red underline here, x, 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 because all of these expressions, these terms here have a x base, then we see that they are in fact alike. Next then, we're going to be looking at unlike terms. Now, obviously, implementing an prefix in front of an actual word will give you the opposite meaning of the word. So it's kind of self-explanatory that unlike terms are algebraic expressions. In fact, when like terms are terms that have the same base, obviously, then unlike terms have different bases. So you're gonna see here that 3x, 4y. Okay, I didn't have these, I'm sorry. Let me just write a few here for you. Thought I had the examples written down already. But say here that you have 4x minus 3y, say here 0.9 p, say here half q. All of these terms here in blue are unlike terms. Why are they unlike? Well, obviously x, y, p, q. That's what makes them unlike. Okay, but there are rules, guys. There are in fact rules to why we cannot add or subtract. There are rules in fact that allows us to either add or subtract or multiply or divide terms. Now, for maths, primarily we find that students get lost with the fact that they try to do and go against the rule that says that unlike terms cannot be added together. So therefore then, looking at this expression here, 3x plus 4y, because they are unlike x, y, some students will say that the answer is 7xy. Well, not when we're adding. If we were multiplying, then we could merge the x and the y, but then again, 3 times 4 would not be equal to 12. So therefore, this is a brutal error when it comes to algebraic simplification. You're not allowed to add unlike terms. Now, the same goes for subtraction. Say here that we're trying to take away minus 3y from 4x. Well, in fact, this is x, this is y. You cannot subtract unlike terms. Hence, therefore, then, the answer cannot be 1xy. Again, if it was, say here, multiplication, then the xy could have been merged together. But then again, 4 times 3 or 4 times negative 3 is not 1. So therefore then that's another brutal error. So therefore, if you in the future find that you're simplifying your algebraic expressions and you get to a point like this, then that's your answer. That's your simplified expression, 3x plus 4y. So then, Now that we have understood the fundamental application of this, what happens now when we're adding or subtracting algebraic expressions? Well, when adding or subtracting algebraic expressions, we must add or subtract, I made a typo error here, their coefficients. That's what we're really adding. Let me pause here for a moment. So many students have this notion, this ignorant notion, and ignorant meaning in a positive way, where they are not aware of what exactly what is meant by adding algebraic expressions. And it's a mere fact that if you understood before you watching this video what these were, then a statement like how can you add x to y would not be a question to be asked. Hence then, we have already gone through the fundamental aspect of this. Now we understand that it's not the letters that we're adding, but it is in fact the numbers that are in front of the letters, or say here variables. And of course, once we add or subtract the coefficients, then we're simply going to rewrite the base. Now, if an expression has two or more unlike terms, then we must group like terms and then simplify. For example then, let's start off with the basics. Here I have an expression that says 4a plus 3a plus 5a. Keeping it simple, building your fundamentals is key, because later on in advanced concepts, all of these are going to be a necessity, a requirement for your understanding and consistency. So here we have 4a plus 3a plus 5a. What we're basically doing, students, is that we are adding or subtracting the numbers in front of the letters. So you'll notice here that I took out the 4 here, 3 here, the 5 here, and I've placed them in a bracket, and then I've rewritten the a. So here I've rewritten the a, and I'm then adding then 4 plus 3 plus 5, which works out to be 12, and I rewrite the base a here. On this example over here, I have 10x minus 12x minus 5x. If a student was ever to get this incorrect, it wouldn't be because they don't know about algebra or they're not very good at algebra. It's the mere fact that the fundamental principle of integers is what's missing, is the gap in your learning. So if before, as you would have seen a link here in the description, down here in the description, and I'll leave a link in the card right here for you, a link that brings you to the channel that teaches you how to deal with numbers like this. I actually showed you two rules, the textbook rule and the Mr. Apex here rule. It's just the O&a-half technique. Just joking around, guys. That's not my method. It's already out there before me. So 10 minus 12 minus 5. For a fundamental student, then I recommend you work it in parts. Say here 10 take away 12 is negative 2. Okay, because then you would have, it's unlike signs. So if we take the smaller from the larger, then obviously we're going to keep the sign of the larger number. So 10 from 12 is in fact 2. Negative is in front of the 12, so we keep the negative. Here I'm then going to merge that with minus 5, minus 2, minus 5. We can use the like signs rule. If the signs are alike, then we basically add both numbers and keep the like sign. So 2 plus 5 is in fact 7, and we keep the negative sign, negative 7x. So that is just basically for students who are not very strong. Of course, you can actually jump from here, come all the way down here. If you are an intermediate level student, you don't have to go through that entire process. Now with example 3 down here, 15x minus 2y minus 9x plus 7y, we have a problem. And can you identify the problem? The expression is not in order. The expression needs some rearrangement. So with the rearrangement required here is that we have to find the term that exactly looks like it has an x. And so here you'll realize that the negative 9x is what's alike to the 15x. So we state the negative 9 and we rearrange it here. Now, a common mistake, and you're gonna see it in future examples, that here we have a positive example. Then students tend to move the 9x and keep the sign that is here. Please note that whenever it is that you are in fact moving a term, you have to move the sign that is also in front of the term. So then if you're going to be moving 9x, we have to move the negative with the 9x, hence why we have this minus 9x here. Then we then safely take this minus 2y here and we bring it down here and add it to the 7y. Now the expression is what I refer to as being in order. Hence then 15 take away 9 is in fact 6x. So 15 take away 9 in bracket, fundamentally, if you're a student who struggles, then you can say here 6x. But an advanced student should be able to move from, say, here, here. You should be able to move from here all the way to here, okay? And so then minus 2 plus 7, unlike signs, so we take the smaller number away from the larger number, which then gives us 5. But the sign of the larger number is a positive, so it's positive 5. And as explained earlier, that in the event that you end up with a finals appearance like this, x and y, then you are not going to get 11xy. Please note, the answer 6x plus 5y is in fact equal to 6x plus 5y. Okay, so I hope that in fact you are getting some value. Hit that like button, guys. Check to see if you are subscribed. This is your opportunity to in fact master algebra once and for all. Of course, please check in the description box below. You will in fact find information as to how to join my live classes, or you can just remain a member and await the tutorials on a weekly basis, weekend basis mainly, for the content. Lots of information is in the description box below. Please read carefully and you may be able to get in touch with me and join my classes. All the pricing details are in the description box below. All right, now let's move on then to some other examples. Then here we're looking at 5x squared minus 2y squared minus 11x squared minus 7y squared. What's the purpose of this example? It's pretty similar to what we just did, but so many times when a student gets flustered, or there's a gap, or there is something that was misunderstood in the fundamentals of algebra, they will sometimes perceive these as being like terms. And what's causing them to think that is the mere fact that the expressions have square, 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 square. Please note that a like term is not determined by the same power, but it is in fact determined by the same base. So even though they have the same power, on the contrary, these are unlike terms. Then, so now we have to look at what term actually has an x squared. So if you'll notice here that this is 5x squared, brought it down here in blue, and then I'll look through the expressions. Aha, there's another expression here that has an x squared, so I move that across beside the 5x squared. Then I have my minus 2y squared instead, minus, aha, another y squared here. Then 5 take away 11, in bracket, fundamentally, if you want to do it that way, x squared, take out the minus 2, take out the minus 7, y squared. This third line here is just for a fundamental student, but if you're an intermediate to an advanced student, you can move from here back to here, okay, by saying 5 take away 11, minus 6, minus 2, minus 7, minus 9. Then here, unlike terms, not by power but by base. Therefore, that is our simplified answer. So then you understand. Let's then look at some expressions that then has composite monomial expressions. So say for example we have here, say 10 a squared x squared minus 9 a x squared plus 2a squared x squared minus 3a x squared. Now you have to be very careful, because in hindsight, just looking at this, if you become slightly distracted or there's any form of gap in your learning, you can get confused. I remember learning math for the first time, and when I saw this, wasn't pleasing at all. I felt so confused because I had a gap in my learning. So I'm here to remove that gap. Let's focus clearly of what type of base does it have. It is in fact what's called here a composite monomial base. Composite meaning more than one joined together to create a base. So the base of this expression here is a squared x squared, as opposed to something like x squared or y squared. Then we have this type of base here. Notice here that the a doesn't have a square, but the x has a square. Now even though they have the same x square, x square, x square, x square, they don't all have a squared. This is a squared, this is a, this is a squared, this is a. So there is some unlikeliness between the terms here. So we can clearly see here that in fact this and say here this are the like terms, and then say here we have this and we have this. Those are the like terms. What next? Then we go on to arranging them. So then we have 10 a squared x squared. Then we join plus 2a squared x squared, because they are alike in blue. Then we have minus 9a x squared minus 3a x squared. Now you can see that they are alike. So we would have learned that this is really 10 plus 2. We're just rewriting the base here. So that's a squared x squared. 10 plus 2 is in fact 12. Then over here, remember that this is a negative 9. So be careful not to make the mistake and say 9 take away 3. It is in fact minus 9 take away 3, which they have the same signs. The coefficients have the same signs. So we're going to add both numbers, so that is going to be minus 12. And we're going to keep the common sign a squared. Pardon me, not a squared. It is a x squared. Alright, so hopefully that is clear. If you walked in an algebra class and you saw this for the first time, you would almost believe that this is a very complicated topic. But if you've been watching this video from the beginning and you've reached this point, you should be hitting the like button by now, because you are in fact, I think and I believe and I honestly know that you have just mastered, or you have unlocked a key towards something that you've been struggling with in the math. Alright, so that is basically the concept behind adding and subtracting like terms. May we round this video out. I'm gonna be here with you for a couple more minutes. So maybe we can look at the fact that it doesn't have to be, say here, 4 terms. We could have something like, say, 2r minus 3s plus 8s minus 2r squared plus, say here, 5r. So what we have here is 5 terms in this expression, and we have to look for the terms that are in fact alike and put them beside each other. But occasionally you might get an expression that has an odd number, an odd term. It doesn't have any like terms. So that basically is a term that we can ignore. We just keep bringing it down until it joins the final result. So here in this example then, we're looking at, say here, 2r. Okay, so we're looking for the term that has an r, and if we scour through the problem, you'll find that, is it this one or is it this one? Well, it has to be this one, because this one has a square. And remember that the terms are not like because of the power, they are like because of the base. So this one goes beside this one, so we end up with 2r, say here, plus 5r. Then now we're looking for, say here, this one. So which one is it? Then it looks to be, it's already grouped beside each other, so that's good. So therefore then what do we have then is minus 3s plus 8s. Okay, then 8s. Then now 4 terms, this is the odd term out. So the odd term out here is minus 2r squared. Has no one to group itself with. So then what is 2 plus 5? That is in fact 7r. And what is minus 3s plus 8s? Unlike signs, take the smaller 3 from the larger 8, that is 5. And then of course the sign that is in front of the larger number is in fact positive, so it's positive 5. Then we have minus 2r squared. This is a trinomial expression in terms of its base, because 3 unlike terms gives us our simplified answer. All right, so that is part 1. That brings us to the end of this particular tutorial. If you need practice questions, you can email me. The link is in the description. You can hit me on any of my social media handles if you need practice questions, or you can just check the description box below. You'll find links that will bring you to useful and resourceful sites for practice questions like these. Definitely check out Third Space Learning. That is an absolutely great platform for learning math and getting practice questions. All right, now in part 2, we're going to be extending this knowledge now to multiplication and division. All right, I do hope that you had and you enjoyed this particular tutorial. If you have cleared up a lot of the misunderstanding that you've had in the past with algebra, hit that like button, leave a comment down below, guys. I'm looking forward to hearing from you all if this is helpful to you. So until then, take care. Bye bye.